The Vendigraph generator was invented by Robert Vendigraph around 1930. Used originally to charge particles in atomic accelerators, nowadays it's used mostly to educate students about electrostatics. It can even make your hair stand on end in a dramatic display of static electricity. We'll see here how it works. The instrument features a small motor that makes a roller at the bottom of the machine start turning. That roller causes a belt to turn, which then causes a second roller at the top of the machine to turn. Two metal combs are positioned very close to the belt, one at the top, one at the bottom, and the whole thing is topped off by a large metal sphere. Although all Vendigraph generators have these parts, they're not all made of the same materials and may work a little differently, but they all exploit the relative tendency of materials to lose or hold on to negatively charged electrons. In our generator, the belt is made of cotton, a relatively neutral material. The lower roller is made of Teflon, more likely to attract electrons. When the lower roller starts moving, it rubs against the belt, setting it in motion while creating friction between these two parts. The friction causes electrons to jump from the cotton to the roller, which becomes negatively charged. The belt is left with a positive charge. This exchange of charges is called the triboelectric effect. Meanwhile, something else is going on in the metal comb positioned just under the roller. Metal is a great conductor of electricity, meaning electrons move very easily through it. Because like charges repel each other, the large amount of electrons that have built up in the roller repel electrons away from the tips of the metal comb, leaving those comb tips with a positive charge. Now there is an electric field in the air between the positive comb tips and the negative roller. As a result, electrons in the nearby air molecules break away from those molecules and go to the positive comb tips. They leave behind positively charged molecules, or ions, which are then attracted to the negatively charged roller. The positive air ions can't reach the roller, however, because the belt is in the way. Instead, they end up coating the outer surface of the belt and are carried up to the top of the machine. The top roller is made of aluminum, which tends to lose electrons. As the positively charged belt rubs against it, electrons move from the aluminum to the belt, giving the roller a positive charge. This positively charged roller attracts electrons to the tips of the comb, creating another electric field that, once again, strips electrons from the air molecules that are inside it, but this time toward the positive roller. The positive air ions left behind are attracted to the negative comb tips. Because the top comb is attached to the metal sphere, these positive charges travel toward the sphere and spread out across it. They will accumulate on the sphere until an object, such as this grounded wand, comes close enough to discharge it. Then, as long as the rollers keep rolling, the cycle will begin once again.